Okay, before we move on to the section 5.3 integral test, let's do some improper integrals from section 3.7. So without any introductions, improper integral, improper, that means our integral is a definite integral, but our two numbers is going to go to either infinity or it's go to the asymptotes, like the vertical asymptotes. So let's looking at the first example. I want to evaluate the integral from negative infinity to 0 of 1 over x squared plus 4 dx. So for those type of questions, we want to evaluating them. Our answer could be the following two situations. Number one is going to be a nice number, or number two is going to be a positive or negative infinity. Then if we do have a nice number, we will say this integral, this improper integral is convergent. And if we have a positive or negative infinity, then we say this is a divergent. So the terminology is pretty much the same, and then the result is pretty much the same. So here we're just doing some examples about how to actually evaluate an improper integral. So the whole integration rule applies here. It's the same. The only difference is instead of we have a to b, two numbers, here we have an infinity. So we cannot really take the infinity. So what we need to do is we need to take the limit. Let's say this is going to be a number t goes to negative infinity of an integral from t to 0, 1 over x squared plus 4 dx. There's not really any particular reasons, just to make it legit. So we take out the limit. So we are not going to considering the infinities here. We're going to treating this is going to be some number. We will just going to do this integrations normally. At the end, when we try to evaluating them, that's the time we will take consideration of the infinities. So for the antiderivative of 1 over x squared plus 4, we can use the rules that this is going to be a tangent inverse. We can using the formulas. So this is going to be a 1/2 tangent inverse or arctangent of x over 2, and then we need to evaluate it from t to 0. Evaluating, we're still not touching the limit portions. Evaluating the tangent inverse of x over 2, we got 1/2 of tangent inverse of 0 minus tangent inverse of t over 2. Where tangent inverse of 0 is going to be 0. And then tangent inverse of t over 2, taking t into negative infinity, this one will give us tangent inverse of negative infinity. And for that situation, according to the graph of the tangent, because this is the inverse graph, we can still using it. So where we have the graph shooting to negative infinity, which is along this portion. So that means the graph, the tangent graph, just making sure this is the tangent. So the tangent graph will go close to negative pi over 2, then we will have negative infinity. So that means tangent inverse of negative infinity is going to be getting really close to negative pi over 2. Then apply it back here, 1/2 multiplied by the negative of the negative pi over 2. We ended up with pi over 4. And that means this is a convergent, and then the integral converges to pi over 4. Now let's looking at another problem. Problem 2, or example 2, we have is integral from 0 to 4, 1 over square root of 4 minus x dx. You probably noticed that this time we have actual numbers, 0 and 4. So it is not an improper integral. But if you're looking at this function, 1 over square root of 4 minus x, what happens when you have 4 is x, like x equal to 4? We notice that this one is going to be discontinuous at x equal to 4. Because when x equal to 4, 1 over square root of 4 minus 4, which is 1 over 0. This is a discontinuity. So, this is still an improper integral, and we still need to take the limit. So we're going to take the limit as t goes to 4 from the left-hand side, because we are going from 0 to 4. The integral from 0 to t, 1 over square root of 4 minus x dx. Then the antiderivative of 1 over square root of 4 minus x is going to be negative 2 square root of 4 minus x. And we're going to evaluate from 0 to t. Which is going to be negative 2 square root of 4 minus t minus plus 2 square root of 4, which is going to be 4. 2 times 2, 4. Now the limit. Since here square root of 4 minus t, we do not have any denominators. So we can just simply plug in the t as a 4. And we ended up with negative 2 times 0 plus 4, which is just going to be 4. So we also know that this improper integral converges to 4. Okay, let's look at another example. Integral negative 1 to 1, 1 over x cubed dx. So for this one, this is also an improper integral, but you probably noticed that why it is improper. We have negative 1 and 1, and none of them will make this one equal to 0. However, between negative 1 and 1, we have a 0. And 0 will make 1 over x cubed undefined. So for this problem, we have to break it as integral from negative 1 to 0, 1 over x cubed, plus from 0 to 1, 1 over x cubed dx, because of the 0, which is the discontinuities in the middle. And we're going to calculate this in a improper integral in 2 parts. So the first part is going to be the integral from negative 1 to infinity, 1 over x cubed dx, which is going to be the limit t goes to 0 from the left side of negative 1 to t, 1 over x cubed dx, which is going to be negative 1 over 2x squared, evaluate from negative 1 to t, which is going to be the limit negative 1 over 2t squared plus 1/2. And this one is going to equals to infinity. It's actually negative infinity because of the negative. And if we do the same thing on the other side, from 0 to negative 1, 0 to 1 of 1 over x cubed dx, it's pretty much the same. We can just copy it, but this time t is from 0 to the t is approaching to 0 from the right of t 1 over x cubed dx. The antiderivative portion is exactly the same. But the evaluation portion is going to be evaluated at t approaching to 0 from the positive side, but still is going to be positive infinity. So we can see that the first part, because of the infinity, this is divergent. The second part, because of the positive infinity, it is also divergent. So, since the integral negative 1 to 0, 1 over x cubed dx diverge, and negative 1 to 0, 1 over x cubed dx also diverge, then the overall negative 1 to 1, 1 over x cubed dx is going to be diverge. Just thinking about that, when I have a negative infinity plus another infinity, is not going to give me any number. Okay, so there are three different situations of the improper integral. And when we're doing the improper integrals, actually evaluating them, there's no difference between the regular integration. The only difference is make sure you're going to put out a two-part. Make sure you're going to identify the discontinuities or the infinities. And then you're going to take out the limit. And when you're evaluating at the end, you're going to take consideration of the limit and then the infinity or the discontinuities.